bright material along the floor of a trough in Noctis Labyrinthus. Many of the troughs, or rounded depressions of Noctis Labyrinthus, contain bright, sometimes layered materials. This high-rise image shows an example of the bright material commonly found along the floors of some of the Noctis troughs. Spectral data from the CRISM instrument, also on board the MRO spacecraft, indicate the bright material is hydrated, i.e. contains water. The hydrated material may have formed when water upwelled into the low-lying depression, or when ice within the trough melted due to heating from volcanic activity. Enigmatic pits and rises in Noctis Labyrinthus. This image covers a depression within Noctis Labyrinthus from rim to rim. Noctis Labyrinthus is a maze of troughs and depressions located at the head of Valles Marineris, the largest valley in the solar system. All these features are indicative of the crust of Mars having been pulled apart, exposing the deep interior of the planet. The depressions are also places where sediments of all sorts would tend to accumulate. When we see strange features on the floor of one of these depressions, it is not immediately clear if it is because of something from deep down being exposed or something relatively young having been deposited here. The enhanced color part of the image suggests that the material on the floor of this particular depression is different than is visible on the walls of the depression. 2 generations of windblown sediments. This colorful scene is situated in the Noctis Labyrinthus, perched high on the Tharsis Rise, in the upper reaches of the Valles Marineris canyon system. Targeting the bright-rimmed bedrock knobs, this image also captures the interaction of 2 distinct types of windblown sediments. Surrounding the bedrock knobs is a network of pale reddish ridges with a complex interlinked morphology. These pale ridges resemble the simpler transverse aeolian ridges, called tars, that are common in the equatorial regions of Mars. The tars are still poorly understood and are variously ascribed to dunes produced by reversing winds, coarse-grained ripples, or indurated dust deposits. High-rise observations of tars have so far shown these bed forms are stable over time, suggesting either that they form slowly over much longer timescales than the duration of MRO's mission, or that they formed in the past during periods of very different atmospheric conditions than the present. Dark sand dunes comprise the second type of windblown sediment visible in this image. The dark sand dune seen just below the center of the cutout displays features that are common to active sand dunes observed by high-rise elsewhere on Mars, including sets of small ripples crisscrossing to the top of the dune. In many cases, it is the motion of these smaller ripples that drives the advance of Martian sand dunes. The dark dunes are made up of grains composed of iron-rich minerals derived from volcanic rocks on Mars, unlike the pale quartz-rich dunes typical of Earth. This image clearly shows the dark sand dunes situated on top of the pale tar network, indicating that the sand dunes are younger than the tars. Moreover, the fresh appearance of the sand dunes suggests that they are currently active, and may help shape the unusual tar morphology by sandblasting the tars in the present-day environment.